Apple is simultaneously hoarding the world's supply of memory chips while planning a laptop that threatens to induce physical exhaustion in anyone who tries to use it. The rumor mill insists hardware engineers in Cupertino are building a new top-tier laptop sitting entirely above the MacBook Pro, tentatively dubbed the MacBook Ultra. We are pulling apart industry leaks, supply chain reports, and some highly aggressive MacRumors forums to figure out exactly what this machine is and why an obsession with extreme thinness is creating a massive thermal and physical engineering nightmare.
Mark Gurman's latest report pushes this entire MacBook Ultra timeline back to early 2027. Global supply chains are choking on a massive DRAM and NAND flash memory shortage. Buying a high-end Mac right now feels like trying to order a massive wedding cake when the entire city has run out of flour and sugar. The raw silicon ingredients simply do not exist in the volumes Apple requires to spin up mass production for a new flagship device.
Hearing the word ultra sets an expectation of absolute abundance. Apple slaps that label on devices meant for uncompromised professional workloads. We are watching a $2 trillion tech giant struggle to secure enough memory to build the machines they already advertised to their most demanding users. Other laptop manufacturers seem to source their components without completely halting production.
Competing brands utilize modular memory designs. They buy off-the-shelf RAM sticks from secondary or tertiary vendors to fill out their inventory when a primary supplier falls behind. Apple utilizes a unified memory architecture for their custom M-series silicon. They solder the memory chips directly onto the processor package to maximize speed and efficiency between the central processing unit and the graphics cores.
Placing the memory on the exact same physical board forces data to travel a fraction of a millimeter. The processor accesses data almost instantly without sending signals across a sprawling motherboard. That architectural choice makes them incredibly vulnerable to supply chain shocks. There is no backup option when the primary memory fabricator falls behind.
Apple even had to completely stop accepting orders for the M3 Ultra Studio configured with 512 gigabytes of memory.
Wait, they just wiped it.
Wiped the option from their store interface. This silicon drought is also delaying the upcoming M5 Max Studio until October 2026. Production lines cannot operate without guaranteed component deliveries.
Movie studios, audio engineers, data scientists, they rely on that massive unified memory pool. They need hundreds of gigabytes of RAM to load entire 3D environments into memory without the system freezing. I saw a comment from a user named Bob Fillmore on Cult of Mac. His Mac Studio crashed right in the middle of tax season. He is stuck moving his backup drive to an ancient iMac because he cannot buy the replacement machine he needs.
When Apple turns off the tap on a flagship configuration, it signals a severe fracture in their supply chain. The factories eventually have to catch up. When they do, the reports point directly to the unreleased M6 Pro and M6 Max chips powering this phantom MacBook Ultra. TSMC will manufacture these chips using their advanced 2nm process.
Moving from the current 3nm M5 architecture down to a 2nm node requires shrinking the transistors to an atomic scale.
Yeah.
Engineers are packing billions of additional transistors into the exact same physical footprint on the silicon die.
It is sort of like trying to pack the entire population of Tokyo into a single city block. Sure, communication between citizens is instant, but the sheer body heat generated in that tiny space is going to be catastrophic without massive air conditioning.
Oh, wow.
Reducing that distance delivers massive speed and efficiency gains over the current generation. The chip computes data faster while pulling less power from the battery.
Denser transistor arrangements allow the central processing unit to execute complex instructions in fewer clock cycles. We are pushing right up against the boundaries of quantum physics. Getting more raw performance out of a processor typically generates a severe amount of heat.
That thermal reality clashes directly with the next rumored design choice for this machine. The MacBook Ultra is expected to get even thinner than the current MacBook Pro lineup. Apple wants to take a machine built for rendering 8K video and compress it into a razor-thin chassis.
Making a Pro or Ultra workstation thinner feels like putting bicycle tires on a dump truck. I spent time digging through the MacRumors comment section, and the community is openly hostile toward this obsession with thinness. One user explicitly demanded the exact opposite of this rumored design. They asked for an 18-inch native 4K brick with a massive battery.
Professional users demand a heavy, durable chassis, prioritizing sustained performance over aesthetics. Shrinking the physical height of a high-performance workstation severely limits the internal volume available for cooling fans and ventilation grills. The physics of airflow become a massive engineering bottleneck when you compress the chassis. Heat has fewer places to escape.
Silicon degrades rapidly when exposed to sustained extreme temperatures. They want a machine designed for heavy computational workloads without the internal fan sounding like a jet engine preparing for takeoff.
They're achieving this extreme ultra diet partly by switching the display technology. Current MacBook Pros rely on mini LED LCD panels. Those screens require a dedicated backlight layer to illuminate the pixels from behind. The MacBook Ultra is making the jump to an OLED display.
OLED pixels emit their own independent light. Slicing that backlight hardware out of the design allows engineers to shave crucial millimeters off the display assembly. OLED technology drastically improves the contrast ratio for creative professionals. Color grading video on a traditional LCD often produces a glowing halo effect around bright objects on a dark background.
OLED turns individual pixels completely off to create true infinite black. It removes the halo effect entirely. We still have to address the physical contradictions of making the bottom half of the chassis thinner. Apple is reportedly keeping the HDMI port, MagSafe, the SD card slot, and a high-impedance headphone jack on this thinner chassis.
They are avoiding a repeat of their previous port removal disaster, where users had to carry bags of dongles just to plug in a camera or an external monitor. Integrating full-size ports requires internal real estate on the logic board. Maintaining those physical ports creates a hard limit on how thin the machine can actually get.
An HDMI port has a fixed physical height. You cannot defy the geometry of a standardized cable connector. If the chassis tapers too much, the port physically breaks through the metal casing. The design requires a thick enough sidewall to house the connector securely. The display itself is undergoing another major physical transformation to save space.
The 2021 notch is out. A hole-punch camera is replacing it.
Embedding the camera behind a tiny circular cutout reclaims pixels previously lost to the rectangular notch housing. Moving to a hole punch paves the way for a dynamic island on the Mac.
We are watching the dynamic island migrate from the phone directly to the laptop screen. We will see low battery alerts, timer countdowns, AirPods connections, and background file transfers dropping down from the top center of an edge-to-edge display.
Shifting system alerts from the top right corner of macOS to the center of the user's field of vision demands immediate cognitive attention. Traditional desktop operating systems keep notifications in the periphery to respect the user's focus on primary tasks.
You are trying to focus on writing code or editing a photograph, and a massive animated bubble expands right in the middle of your eye line to tell you your mouse battery is at 10%. It turns a subtle peripheral notification into a mandatory visual interruption.
That display rumor is mild compared to the most inflammatory one. The MacBook Ultra will feature a touchscreen.
Steve Jobs famously decreed that a touchscreen Mac would cause arm fatigue. I found a direct quote from a furious McRumors commenter named NickSub1. They stated that if someone tries to touch their laptop screen, they will recoil my arm with a fist.
Apple frequently reverses its rigid philosophies when market pressures shift. We saw the introduction of smaller iPads and larger iPhones after leadership explicitly dismissed those form factors. Adding touch capabilities to a desktop operating system requires a fundamental overhaul of user interface mechanics.
Reaching across a physical keyboard to interact with macOS via touch on a traditional clamshell hinge creates an inevitable ergonomic nightmare. If you are listening to this right now on a MacBook, try lifting your hand and touching your screen to pause this audio. Do that repeatedly for an 8-hour workday. Your shoulder will scream.
You are fighting basic biomechanics. Gravity pulls your arm down the entire time. Ergonomic researchers document this as the gorilla arm phenomenon. The human arm gets incredibly heavy and cramped after just a few minutes of vertical manipulation.
Biomechanically, the deltoid and bicep muscles are forced to sustain an isometric hold. The tension builds continuously without any skeletal support resting on a desk.
You are also dealing with the psychological horror of covering a pristine, high-contrast OLED display in greasy fingerprints. You spend thousands of dollars on a machine with perfect color accuracy, and then you smear skin oils all over it.
The display requires constant cleaning just to remain usable for professional color grading. Another commenter noted that unless you fold the screen backwards and use it laying down, a touchscreen on a laptop remains an absolute gimmick. They said disabling the touchscreen is the very first thing they do on their Windows Work laptop.
Touch interfaces demand large, widely spaced buttons to accommodate human fingers. macOS relies on the pixel-perfect precision of a mouse pointer. The interface utilizes tiny close buttons and dense drop-down menus designed specifically for a trackpad or external mouse.
You constantly switch physical contexts. You move from resting your palms on the trackpad to hovering your arm in the air. A user named GermanBeer007 brought up how clunky touch targets function in reality. They sarcastically mention how much they love pressing the tiny red button multiple times on their iPad just to close an app.
Modifying the operating system for fat fingers dilutes the professional desktop experience. Apple historically kept iPad OS and Mac OS separate to avoid compromising either platform. Merging touch mechanics into Mac OS forces developers to build applications with massive buttons and simplified menus, degrading the density of information professionals require.
If the user is exhausted from holding their arm in the air to touch the screen, Apple at least wants to make sure they aren't also fighting to get online. The final rumored feature fixes a long-standing point of friction for mobile workers. We might finally be freed from the tyranny of the personal hotspot.
The MacBook Ultra is slated to include built-in cellular connectivity. Integrating 5G and LTE access relies on Apple's proprietary C1X or future C2 modem.
Anyone trying to use a public Wi-Fi network at a coffee shop knows the pain. You spend 10 minutes fighting a captive portal that refuses to load. Frustration sets in, and the iPhone hotspot becomes the only option. Waiting for the network to appear in the drop-down menu takes forever. Once the connection establishes, the phone battery drains at an alarming rate.
Built-in cellular solves all of that. Your laptop connects instantly, you flip open the lid, you bypass the insecure public Wi-Fi entirely, and you have broadband internet immediately.
Searching for a 5G tower from inside a concrete coffee shop is like screaming across a crowded stadium to a friend on the opposite side. The effort requires maximum energy and generates massive internal heat.
Apple engineers must dissipate that localized modem heat inside a chassis, actively losing internal volume. They are stacking a hotter 2-nanometer processor, a heat-generating 5G modem, and a battery constrained by a thinner casing.
They are building an impossibly thin metal wedge crammed with the most dense silicon on the planet. By the time the global memory shortage clears and 2027 finally arrives, will a thinner touchscreen Mac actually feel ultra? Or will it just feel like Apple charging a premium for a feature their own power users actively want to punch?
I guess we wait for the factory lines to spin up.